Good day and welcome back to Everything Mathematics. Today we're going to continue our series on factorization. However, today I thought it would be wise to just look at the whole notion of expanding an expression. In that way, when we go into the AC, completing the square and even the quadratic formula, we will have a better appreciation and understanding as to how to expand. So our objective for today, we're going to look at expanding algebraic expression, and we're going to also be looking at understanding the distributive law. And expanding is all about really and truly using the distributive law. So the distributive law simply states this here. So if we have A being multiplied into B plus C, the distributive law simply states that you could multiply the A by the B and the A by the C. As a result, we get AB and AC. And that's all we're saying with the distributive law. Algebraically, this is the same thing we're doing, but when dealing with algebra, you'll have a situation like this. Supposing we're doing the HCF method, or you could end up with a scenario like x plus 1 all multiplied by x plus 3. So these are the two main scenarios you will bounce up with when you're dealing with distributive law and algebraic expression. And in the next slide, I will show you how to do one like this. So let's move along. So here we have an example, well, two examples, how we can expand expressions of such a fashion. And again, it's all about understanding the rules, all about understanding the procedure. So the procedure goes something like this. And there's no one way about it, there are many ways, but I think the easiest way is taking this approach. This x you multiply by this x, and this x you multiply by this 3. And then you do the same thing again, but with the other number. So this 2 now will be multiplied by this x, and this 2 now will be multiplied by this. I should use different color codes. Let me use different color codes. So red, x by x. Good. Let's try yellow, x by that. Let's try a green, 2 by x, and let's try a blue, 2 by 3. Right? And when we solve this, this is what we're supposed to end up with. So x in the red, x multiplied by x, we should end up with x squared. Good. Then we go to the yellow. In the yellow, we have x multiplied by 3. So that should give us 3x. Then we go to green. We have 2 multiplied by x. So that should give us positive 2x. And that takes us last but not least to the blue. 2 multiplied by 3, and that should give us 6. And that's all we do when we expand really and truly. And when we finish expanding, of course, we could simplify if we could simplify. So here, for instance, 3x is simplifiable with 2x. So we could have 3x plus 2x. So our final root here would be x squared plus 5x plus 6. This should be our final answer in a case like this, because 3x plus 2x is actually 5x. And yeah, that's how we expand. In the second example here, this one is more of a disguise, but the concept is the same. So z plus 9 all squared is actually saying z plus 9 multiplied by z plus 9. Yeah. And once we do that, we follow the same routine. Z by z, then we have z by 9. Then we have 9 by z, and then we have 9 by 9. And if I do that, I see here that I will end up with z by z will be z squared. Let me make all my z's the same. So that will be z squared. Then z by 9, that will be 9z. Then the next 9 by z, that will be 9z. And then 9 by 9, that would be 81. And notice these two 9s here could simplify. They have a unit, a coefficient, but they also have the same unknown factor. So this is the same thing as z squared plus 18, z plus 81. And that's our solution there to that expansion there. Good. So let's see if we could do some now, and this is just for practice. So of course, this is the part of the video where you could pause it and then see if we get the same answer, but I will just move on and you will just meet me when you finish. So for the first one, This is one of the simplest way it could come. So remember, this is the distributive law. So 4 times x and 4 times 5. And that will simply leave us with 4x minus 20. And that's the answer. 4x, 4 times x is 4x, 4 times 5 is 20, minus 20. Because the negative, it's negative, so we have to respect this sign. If it was a negative 4, by the way, negative 4 by negative 5, then it would have been positive. But that's not the case here, so we can't do that. Good. And here now we have our routine expansion. And again, I'll just draw the arrows. This by this by that, then this by this, and then this by that. Notice that this 3 here is negative. Notice that. Very important to observe your signs. So now I go to x by x. That should give me 2x squared. Then I have 2x by 4. That should give me 8x. Minus 3 by x. That will give me minus 3x. And minus 3 by 4. That should be minus 12. And here the x's can compute again with each other. So that's 8 minus 5. So our final answer should be 3x squared plus 5x minus 12. And if you got that, we're good to go. That should be correct. Let's go. Right, so for the next one, C, we have, again, this one is a simple distributive law. Well, all of them are basically distributive law. So we have this by that, and then we have this by this. So let's see what happens when I solve that. 3x by 8, I'm supposed to get 24x. 3 times 8 is 24, and well, the x remains, plus 3x by 2x, that would be 6x squared. Shoot. So if this x was not squared, we would have had a scenario here where we could have probably add the 24 and the 6 to make it 30. But because the unknowns are not the same, we cannot add these two. So yeah, this is as far as we could go, and that would have been our answer. And in this last one here, 8 plus x, again, it's all squared. So we have 8 plus x, and then we have 8 plus x. Good. And from here, it's just a matter of expansion. So we have, let me use a red arrow for this one. So we will have 8 times 8. We will have 8 times x. And notice the positioning in this one is a little different. But again, the rules remains the same. So it doesn't, who says the x have to be first? And I think that's something that will struggle for a lot of students. I guess they think that you have to get your x squared term first. Generally, yes, you want it like that, but it doesn't always have to be like that. You could always rearrange it after if you want. And I'll show you that too. So here we have 8 times 8, that is 64. Then we have 8 times x, that will be 8x. Then we have x times 8 again, so that will be 8x. And then you have x times x, which will give us x squared. And this is the same as 64 plus 16x plus x squared. And again, as a general rule of thumb, and well, in algebra, when you reach higher levels of algebra, it is commonly acceptable that you always set your unknowns in order of highest degree to lowest. So, and that's in terms of the power. So notice that the x squared is higher than just the x. So ideally, you want the highest power to come first, and then you break down. Second highest power, and then of course, no power, or you could say this is the same as 64, x to the 0. So this is like x to the 1, x to the 0, x to the 1, x to the 2. So it's like we're coming down in terms of the degree of the power. And you should know by now that anything raised to the power of 0 is 1. So it's like this one doesn't show up, but it's there. And that's basically what is taking place there. So I trust that you would have gotten all your answers correct. This is as far as we go for today. So as always, again, feel free to like, share, and subscribe. And until the next time, tomorrow, we're going to be looking at factorizing using the AC method. Until then, you take care.